Welcome to Teja Statistics. Today we are learning about statistics paper 6, that is ANOVA one-way classification. So ANOVA one-way classification, let us suppose a sample of n values of a given variable by in subdivided into k classes of size wij, where I equals to 1 to k, j equals to 1 to n respectively, such that summation I equals to 1 to n, ni equals to capital N. The one-way classification data can be represented as follows. You can see, here is your observations. So y11, y12, y1j, y1n. Second classification or second row, y21, y22, y2j and so on y2n. Similarly, if you consider the ith value yi1, yi2 and yij minus and so on yin. So I values are have taken here, that is 1 to k. So variable values these are, and the totals t1 dot first row classification total, and the mean also y bar of 1 dot, y2 dot and y bar of 2 dot and so on. In general ti dot and y bar of I dot, and total is called grand total, that is denoted by G, capital G, and means of mean is also denoted by y bar double dot. So where G is the grand total, y bar of double dot is overall mean, the data is called one-way classification data or one-way classified data with equal number of observations. So the total variations in the observations Yij can be divided into two components. So these are the conditions, or we can say that the variations in between the classes and within the classes. So this is due to assignable causes which can be detected and controlled. Variation within the classes, that is inherent cause. This is due to chance cause which cannot be controlled of human hand. So these are the two conditions. Next, sources of variation in this data. Effect of the treatment alpha I equals to 1 to k, and error due to the chance iij or epsilon ij follows the normal distribution. So the mathematical model of ANOVA one-way classification is given by the linear mathematical model of one-way classification will be yij is equals to mu plus epsilon ij, where yij is the yield of the jth unit in the ith treatment and epsilon ij is the error effect applied to the ith treatment, and epsilon ij is the error effect, and mu I is fixed effect due to the ith treatment. Okay, consider the model yij equals to mu I plus epsilon ij, and add and subtract mu to that above. So yij is equals to mu plus mu I minus mu epsilon ij. Here the equation model is given by yij is equals to mu plus alpha I plus epsilon ij, where alpha is equals to mu I minus mu, put as equation 1, where mu is the general mean effect and mu equals to 1 divided by capital N double summation of mu ij, or else we can write it mu equals to summation I runs from 1 to k n into mu I divided by capital N. Alpha is the effective due to the ith treatment, where alpha is equals to mu I minus mu, and mu I is equals to 1 divided by n summation j equals to 1 to n of mu I. Consider now we consider summation I runs from 1 to k ni into alpha I value. I runs from 1 to n, that is ni into mu I minus mu, where I equals to, if you apply that one to the both summation I runs from 1 to k ni into mu I minus summation I runs from 1 to k n to ni into mu. So both are will be the same, that is mu into n minus mu into n. So if you get the value of, in the derivation, if you got any summation I runs from 1 to k ni into alpha I value will be the 0. To prove these assumptions, we have to consider the assumptions, that is all the observations of Yij are independent, various effects are additive in nature, epsilon ij are identically independent distributed, follows the normal distribution with 0 comma sigma square. We are supposing the null hypothesis to the above mathematical model. We have to test the equality of the population means. So we are considering that we are testing the homogeneity of different treatments. So null hypothesis is formed like this: H naught is equals to alpha 1, alpha 2 and so on alpha. Okay, notations and formulas you can see over here, that is yi bar dot is equals to 1 by n summation yij, mean of the ith treatment. Y bar double dot is the mean of the total overall mean. Okay, consider the mathematical model of the equation 1, that is yij is equals to mu plus alpha I plus epsilon ij. Now we have to estimate mu and alpha in the equation. We have to minimize the error epsilon ij. Hence, by using the principle of least squares, the error is equals to the sum of squares of the deviation of the observations is minimum. So this is the Legendre's principle, which we already know. So the epsilon value we have to be vanish. So we are considering E equals to double summation yij minus mu minus alpha I whole square is the minimum. Now differentiating with respect to the mu on both sides and equating to 0. So dou E by dou mu equating to 0, that implies the dou of that function. So E is a double summation yij minus mu minus alpha I whole square. So if you differentiate that one and equating to 0, then you will get the value as y bar double dot is equals to this mu. Put it as equation number 2. Now to find the value of alpha I, differentiating with respect to the alpha I on both sides and equating to the 0, then you will get alpha I value as this yi bar dot minus y bar of dot dot equals to the alpha I value. This value moves this side. Okay, so substitute that value in the equation 1 to get the value of epsilon ij. So yij minus y bar of I dot, that is error estimate. So put it as equation number 4. Now substitute By substituting equation 2, 3, 4 in 1, we get the model. So Yij is equals to y bar of dot dot yi bar of dot minus y bar double dot plus Yij minus y bar of I dot, and summing and squaring over here on both sides, then we will get the mathematical model with the respective frequencies and degrees of freedoms. So the total sum of squares is equals to sum of squares due to the treatments plus sum of squares due to the errors. This can be written as like this: TSS is equals to SST plus SSE. So the degrees of freedom is like this. Total number of observations are n minus 1 is the total sum of squares degrees of freedom, and SST number of treatments. So how many number of treatments are there? We are supposing the value as I. So I runs from 1 to k. So k minus 1 is the degrees of freedom for these, and errors, if you subtract both two, then you will get capital N minus k. So we are preparing one excellent table to understand that one, and this is called any sum of squares divided by its degrees of freedom follows the chi-square distribution. So this is can be called as mean sum of squares. So that is SST divided by k minus 1, SSE divided by n minus k. So we are denoting with ST square and SE square. So the test statistic, here we are supposing a test statistic chi-square distributions no. So we have to apply that F test statistic. So this is the ANOVA one-way classification table, very important table. Okay, sources of variation, degrees of freedom, sum of squares and mean sum of squares, and the final F test statistic. So k minus 1, n minus k, and capital N minus 1. This is the total value. These are the formulas for here, and mean sum of squares also we are substituting ST square divided by SE square follows F k minus 1 and n minus k. So conclusions, we can make the conclusions. If calculated value of F is corresponding treatments is less than or equals to the critical value of, that is stable value, then we accept H naught, otherwise we are going to reject the H naught. So what we can say, that is there is no significance difference between them, the treatments. So this is how we have to follow that one. So this is the calculation we are doing. Okay, this is ANOVA one-way classification, and up to ANOVA one-way classification final table you have to write. This is very useful to understand and easy way to understand about the ANOVA one-way classification. Thank you.